how the plane Okay, first of all, what is Concord? Concord was a supersonic jet which was being used for a commercial purpose in 1960s. It was started from 1960s. It was built in 1960s, by the way. So I should use the word was because it was in 1960s. And there was one incident which took place when this aircraft was totally shut down. The reason was that there was a metal sheet in a runway. What happened was that due to the external factors, that metal sheet went into the fuselage of the fuselage. Actually, the fuselage it's here below the wing. Actually, it's here somewhere. This area, the fuselage is here. So then what happened is that this metal sheet went and hit this part. Then the engine is also contained here, this part. So it hit this part, and then the fuel then the crab deepened, and then the fuel started to come out, and it directly went inside the the engine, and then it started to produce the fire. So the pilots lost the control and went to a tragic. So I'm going to talk about the nose part. So this is how the nose looks. This portion is when the flight is at the cruising speed, like about it crosses the sound barrier. So what happens is that this is a retractor portion. So the front part, it comes down a little bit, and the cabin windows are here. So to prevent the heating of the glasses, this comes down. Because the pressure increases at an altitude, right? It goes in 39,000 feet and the pressure increases. And this starts to heat up and then it will lead to melting of glass and all. So this goes down. So this is at a cruising altitude. And for better aerodynamic design and to achieve the speed of sound, it takes that shape. Then then the next question comes where the nose goes down to 5 degrees. It goes down to 5 degrees, and there's something called a visor. There's something called a visor jack here, and there are hydraulic kind of suspension kind of stuff. What happens is that this pushes it up. It comes down by 5 degrees. So this is very favorable for the takeoff of the plane, and it will give a better lift off. Then this is the 12.5 degrees. It goes down to 12.5 degrees, and this gives a better. This reduces the speed actually. It goes down to 12.5 degrees. To control the speed of the aircraft, from 5 degrees it goes to 12 degrees, and this would like slow down the speed of the plane. So that is the procedure of the nose, by the way. Whatever I explained here, and it creates sounds anyways. Due to the high speed, it creates vibration and the sound. Sir, this is just a study about whatever I told is Okay, the whole at an altitude, what happens is that the nose gets heated about 130 degrees Celsius. So once they painted the flight this color, this advertisement was being set up in the flight. So what happened was that the whole paint got melted up and it started to spoil the plane's exterior part, because that was getting heated up to 130 degrees Celsius, right? So next time giving a mic to Ashwin for telling the aerodynamic design of the engine.
So I'm going to talk about the aerodynamics of the engine. So the air comes to the left and goes to the right. There are two nozzles, the primary nozzle and the secondary nozzle. The two nozzles are there to control the thrust of the engine. To understand that, we have a few graphs. At the speed of when the velocity of the air is less than Mach 1, when the area keeps decreasing, the speed increases up to Mach 1, and after that, when the area is increasing, it goes back to lesser speed. When the speed of air is greater than Mach 1, the complete opposite happens. When the area decreases, the speed decreases, and then the area increases, the speed increases. So to get optimal speed for takeoff and landing, we use both converging and diverging nozzles to control the speed and to get varying configurations. And at supersonic speeds, the engine can't handle air. So for that, there are a few intricate designs. Right. For takeoff, we need a lot of air to start up the engine. So the ramp doors are open, and the spill doors take in extra air, and the bypass doors for the cooling gets closed to get maximum intake. So for supersonic speeds, we don't need a lot of air. So the ramp doors open up, so that the air is converging, and we saw in the previous graph that when the air converges, the speed decreases. So the speeds decrease to ease the combustion, and the bypass doors are open for cooling. These just explain what I said. Yeah. Next, Siva will be explaining about the delta wing.
Am I audible? Yes. I am here to talk about delta wings. Can anyone guess what it means from the name? Delta wings are wings which has the shape of a letter delta from the Yeah, it's obvious, everyone knows this. Well, why we use delta wings in the delta wings will be in triangular shape. From the picture you can clearly see it is like a triangular shape. So usually we use this kind of wings in high speed airplanes or jets, but in Concord they use this because Concord can travel faster than sound, like Mach 1.5 to 2. So in order to create lift at that high speed, we should use this special kind of wings. Yeah, that's what I told. We use delta wings in Concord because generally, how many of you know how an aeroplane works, like wing of an aeroplane? So generally, let's assume this is the cross section of the wing. How airflow will be like? It will design in such a way that more air will flow on top of the wing compared to downwards. So we know that if velocity is more, pressure will be less. So if more air is flowing through here, then there will be low pressure, and here will be high pressure. So this difference in pressure creates a lift. That's how normal planes work. But in Concord, it is very different. Next. How delta wing work? So delta wing will create a vortex kind of thing. So it is like a vortex. So it is very attached to this wing. So in order to attain this vortex, we should use very high thrust speed, like Olympus engine he told. we need to travel at high speed in order to make this delta wing work. So so in aeroplane, if you have very high angle of attack, which means if you go very steep, the airflow will separate. So there will be no air in this region. So there will be no pressure will be created. So this condition is called stall. But in delta wings there will be no stall because of this vortex. It is very attached to the wing itself. So I will show the smoke simulation for this. Next. So here this is a normal aeroplane wing. So you can clearly see that after sometimes there will be no air in the top surface of the wing. So this condition is known as stall. So normal planes cannot have high angle of attack at high speed. But in a delta wing it's possible because of this two kind vortex. So this thing is very useful at high speeds. That's why they use this delta wings in Concord. So the major disadvantages, as I told before, we need very high speed in order to make this delta wing work, and it's less stable compared to other wings. So we should add some other stabilizers for this. Thank you. Next, my friend will talk about.
So hi all, I am here to talk about the disadvantages of the Concord flight. We've been talking all this while. So we heard Vaishnav giving a hint about the heating issues of the nose part, and I'll explain it here in detail. So the Concord flight is designed to travel in more speed than compared to the normal flights, which has a special aerodynamic shape in the nose. But it actually turned out to be a disadvantage too, because when the wind currents hit the aerodynamic nose in a high speed, it started heating up. And in this variant, especially called the TU-144, had its engine in the nose. So both the engine's heat and that dynamic heating added up to everything, and the cockpit started getting heated up. So they tried many ways, and one of the ways to remedize this was white painting the nose. It was helping to resolve this issue, like up to 6 to 11 degrees, but anyways it was not that useful. So it was one of the major disadvantages. Due to that heating, it caused the thermal expansion of fuselage. Fuselage is another major component of an aircraft, like the cockpit and the fleet blades and sort of things. It was also a disadvantage. So this is a diagram indicating the heat levels of various parts of the aircraft when in a critical state of Mach 2. Mach is something related to the speed of the aircraft in relation with the speed of sound. In Mach 2 speed, that is more than the speed of sound, this will happen to the aircraft. So moving on to the structural issues of the aircraft, we have this Concord traveling in high speed, due to which large forces are applied during the banks and turns. So it obviously causes twists to the aircraft structure. Center of pressure of this aircraft shifts rearwards when this happens, and both the center of gravity has to be maintained at a stable position. In order to ensure that, they try to redesign the blades and pleats. Still, only 2 meters of center of pressure shift was able to be maintained. It sometimes went over that, so the bending of nose, very mild bending, also was caused due to this.
So I am going to tell about the remedies, some general remedies for supersonic planes. First one is fuel efficiency. So these engines of the supersonic planes are very much consuming, which those engines will consume fuel more, and some ways for this. Sorry, just a minute. More efficient engines and more fuel efficient engines can be used to correct this jet's engine. And some airlines have they don't prefer these jets as of lower capacity. These supersonic jets have the capacity of 92 to 128 per passengers, which is low compared to other subsonic planes. But if the capacity of these planes if increase, that's increase in the marketing value of these planes. Next, structural integrity. It's this plane is a more complex structure. So maintaining these planes is very tough and it takes more cost. So implementing more cost efficient ways and planning more flight schedules can decrease the fuel consuming capacity. If you can decrease the fuel consumption of these planes and increase the cost in managing these planes. And this is one of the biggest problem faced by these planes. During supersonic speeds, these planes get superheated, and it is even explained by Shashaank. So white paints are used to cover these planes, which is and these planes are covered with white planes, which are 2 times effective as paints which are used to other planes. And a special aluminium alloy called AU2GN is also used, which is more lightweight and more heat tolerant even than titanium. And this is the major reason why this plane is banned in 1973. It's because of sonic boom, which is at sonic speeds. These planes break the sound barrier, which makes a heavy noise. So it's, due to some problems, they banned this. So some noise suppression devices can be used to suppress these sonic booms. So they will control the exhaust gases which goes through the exhaust nozzle of the plane. And the future of the sonic planes. So NASA is thinking of making the supersonic planes in a quite manner. So they have implemented 3 ways in doing it. So they made the delta wings so large that it can move at more speed, and it has a very streamlined body. So the sound barrier is like a surface, imaginary surface, in which if the plane is made more streamlined, the area of the plane will be so less that the sound made by this will be more less. And finally, a long narrowed nose is also made, which NASA even implemented these features in a plane, and it's called H59. So it has a long narrow nose of. Thank you.